Hello. As you can see, when we are doing calculus, we need algebra. We need algebra a lot. This week, we covered one definition, one theorem. And when we apply these definitions and theorems, and we need to know how to do the algebra properly. And this lesson, I will be talking about how to just help you to review the algebra. And I will also point out the places that, what the books you may want to get to study some more. I put a lot of materials on the first week, right? So these lessons, I know it may look overwhelming to you, but these are the minimal. These are the minimal information you need to know about before you enter calculus. Okay, if you have trouble or you don't know about these things, you forget about them, you will have to learn them all at once. So that's why we say this is this is 7 courses in one. If that's the case for you. So the first week, second week, we spend a lot of time on the algebra, but still, this may not be enough. Your 4 quizzes are primarily on algebraic because I want to find out how much you know, how much you don't know. And sure enough, I found something, and I still will continue to learn about you. Okay, so I can help you better. But today, I'm going to just look at some of these topics, right? I recommend you guys to study. For example, last week I recorded solution to entry quiz to calculus. And this, even though it's almost 2 hours, but there's so many things that you are going to use in calculus from algebra. You need to study. You need to study. Okay. So watch this, maybe in intervals, right? You watch 30 minutes or 20 minutes at a time. And I put them together because if I make the lesson too short and there will be too many lessons, right? And the next one I talk about in class was mathematical principles. There are 6 mathematical principles. And in this lesson, when I was talking about mathematical principles, there are many examples that are related to algebraic questions. And the grammar of mathematics, only 16 minutes. Number system, only 13 minutes. And truth table. I consider all of these 3, right? Mathematical principle, number system, grammar, the truth table are basic. But we use them very often. We use them very, very often. And we reviewed some functions here, right? Especially absolute value function. We're going to use it a lot. And I was telling my pre-calculus class students, every semester I tell them this is about 20, 30 points that you can get or lose in your calculus class. And sure enough, and you will find out for sure because you are taking that calculus class. And review of functions, right? At the entry, as you can see, the first definition, right? What was the first definition you learned in calculus? The first definition is right here, right? Is limit, intuitive definition of limit. And in this definition, what is being talked about? Suppose f of x is defined. This is about function. This is about function. Everything you do is about function, of a function of various sort. Okay. In your algebra classes, we learn a lot about functions. There are many, many different kinds of functions. All of those different kinds of functions will show up. So we have a review of functions, x cube function, which is going to be used in calculus, the root function used in function, exponential logarithm function, which is going to use in calculus, and exponential logarithm properties, common mistakes, and sine, arcsine, all these trig functions and compositions piecewise function. So I really just put some minimal material for you to review. And you should try to do it a little bit at a time, And today, in this lesson, I'm going to review with you. Okay, just to the, what do we do this week? And we're going to do those algebraic skills. Okay, we're going to work on those algebraic skills. And the algebraic skills, we're going to work on these, which is some in class. And the next, we did not get to do in class, but you have seen them, right? We've done some rationalizing numerator in the diagnostic test in last week. So I thought you guys should be able to work them out. And these are the real questions you're going to see with limits in your next week. Okay, so let's recap some of the questions we did. Okay, and some of the questions we didn't do in class that you might have questions. So I'm going to work with you on that. Okay, I'm going to show you how to do the factoring. Okay, so I'm going to cover a little bit about factoring. Okay. The first one I already covered in the other lesson, so I'm not going to repeat it, right? How about number 7? Right, this is a complex fraction. Number 5 we did it in class. Number 7, okay, so let's look at number 7. The algebra, okay, so week number 2 on algebra. Okay, so we're going to reduce this fraction. We're going to reduce this complex fraction. Okay, complex fraction, 1 over x minus 1 over 3 divided by x minus 3. So we have this function. We're not talking about limit. We're just talking about how you're going to reduce it in algebra, algebraically. Okay, I'm going to make this little font a bit larger because the complex fraction situation. Okay, when we write equal sign, we need to make sure the central fraction bar is aligned with equal sign. Okay, so don't mismatch it because it could cause confusion. All right. So this complex fraction, and typically for complex fraction, we simplify by finding the common denominator. The common denominator here is 3 times x. 3 times x. Okay, 3 times x. 3 times x divided by 3 times x as 1. So we're applying mathematical principle number 1. Okay, and the next step you would do is you're going to multiply the 3x to each one in the numerator. So numerator times the numerator. Denominator times denominator. So I'm going to just put it here, and I'm going to just put 3x. As we mentioned, we can remove that. We want to have a factored form. Okay, all throughout the calculus 1, you will find that we like factor form. Factor form give us a lot of convenience. Okay. The denominator, I'm not going to multiply it out. I'm not going to expand it. I'm just going to keep the factor form. On the numerator here, x and this 1 over x, that makes 1. And the 3 times 1/3 equals 1. So 3 minus x. And then what? Well, 3 minus x and x minus 3, these two are opposite. Okay, so I'm going to keep the denominator 3x times x minus 3. I'm going to write the numerator in a slightly different form, which is minus x minus 3. Okay, if you have any questions about that, just check. Okay, you probably, this were taught in elementary algebra in case you need more practice. Okay, x minus 3 is the opposite, or we can write it this way. Okay, 3 minus x. You can go ahead and verify this. Okay, verify. 3 minus x is a negative x minus 3. And we get x minus 3 here, x minus 3 here. Well, the domain is not going to be x equals to 3. Therefore, x minus 3 is not a 0. Therefore, we can reduce. So after that common factor is gone, we will have negative 1 on top. And in the denominator only says 3 times x. So this is how you can reduce that fraction. You can reduce that fraction. Okay. Let's look at another example that you can work algebraically. How about number 8? Number 8, right? Number 8. So let's go back to number 8. Okay. So we'll call it example number 1. Example number 2. Right, we have a fraction. And we have 3 plus h raised to the power of a negative 1 minus 3 raised to the power of negative 1, and we have a h. Okay, let me make sure I copy that question correctly. Yes, I did. So let's come back. So we're going to reduce this. So now we only work the algebraic part of this. Okay. Because the other part is your homework. Okay, I don't want to take away the opportunity for you to practice and try something and think about it. Okay. All right, but if you have any questions, don't hesitate to reach out to me. I'll be happy to answer your questions. To reduce this algebraically, okay, first we need to understand some algebraic notation. Okay, b raised to the power negative n is equals to 1 over b raised to the power of n. N can be any real number. N can be any real number. And of course, what if n is 1? Right? If n is 1, so this is going to be 1, right? B to the power 1, we can save the 1, right? So that's what the 3 plus h equals to the power negative 1 is about, right? So 3 plus h to the power negative 1 is really what? It's really 1 over 3 plus h. Okay, I'm gonna put this, you can also say it's a scratch paper. Okay, scratch paper. Most of the time, your teacher doesn't need to see this, okay? And of course, 3 to the power negative 1 is 1/3. I'm going to remove the negative sign. So this is just going to be 1/3. So now we have another way to write this expression, right? It's going to be 1 over 3 plus h minus 1/3. And then we have a denominator h. Okay. So now, this one is actually similar to what we did earlier. Okay. Except the common denominator this time is going to be 3 times 3 plus h. We need a parentheses for 3 plus h. And so we're going to multiply that common denominator on top and bottom. We multiply by 1. So this is 1, right? And replace 1 by this quantity. Okay. And then we got numerator, multiply numerator, and we're going to distribute that. Right? Denominator multiply the denominator. Okay. And we keep it in factor form. We keep them in factor form for as long as we can. And then we can certainly put the 3 in front, right? If you like it that way, I like it that way. So 3 plus h and 1 over 3 plus h, that would reduce into 1. And 3 times 1/3 makes 1 again. And we are almost done. So now we're going to open up the parentheses. So the negative sign is going to apply to 3 to h. We get a -3 minus h. Okay, be careful. If you forget to change to minus to minus h, you keep that plus h, you are making a mistake. Okay, so the next step would be just a negative h. Now h and h can be reduced, right? So in the end, we are getting this h is gone, and this is just -1. Sometimes you may say, do I have to show so much work? The answer is not necessarily. In fact, for example, if you show work, right? In terms of showing work, you don't have to show so many lines. Okay, I show so many lines because I want to be prepared for anybody who might have questions. For example, right? This step can be gone. We don't need that step, right? And we don't need this step either. So given, add 1 step or subtract 1 more step is okay. Because when I'm checking your work, I just need to check if the latter one is the same as the previous as you declare. Also, about equal signs, some people tend to use arrow. Please stop using arrow if equal sign is justified. Equal sign means is the same as. Arrow has a lot of other meanings, okay? But it is not as strong as equal if the two quantities are the same. Then you should use equal sign. Okay, I have some explanations about it in the other lesson. So please do pay attention. Please do pay attention. Is the latter one equals to the previous, right? So is the latter one equals to the previous? If it is, and you use equal sign, you make that relationship weaker. And I would take points off. Okay. So please be careful about the notation. Be careful about the notations. Okay. Let's see. We should do some more. We did that one already. And number 6 and 11 are rather similar. So we talked about that method earlier on. So now you can work on all the limit. For the radicals, for rationalizing the numerators, and I think if I do, I will make a separate one. But for this lesson, I think this is long enough. I try not to make it too long. So thank you for watching, and I need to make some adjustment, make some corrections here. Okay, until next time, thank you for watching.